Imagine for a moment a cosmic dance where Earth and the Moon are partners forever twirling in space. But how did this dance originate? The Moon, our closest celestial neighbor, has been a subject of fascination and intrigue for centuries. Its formation remains one of the greatest enigmas of our time. Theories abound, each trying to explain this celestial mystery. Some suggest a massive collision, others propose a simultaneous creation, and yet others speculate about a rogue planet captured by Earth's gravity. Each theory, as varied and unique as they are, attempts to decode the secrets of the Moon's birth. It's a cosmic detective story that uncovers clues about not just the Moon, but also our own planet's early history. But the truth is, we are still dancing in the dark, searching for the light of understanding. Every dance has a beginning, and so does the Moon's. Let's delve into these theories and unravel the mysteries of our cosmic partner's formation. The Fission Theory, one of the earliest theories, suggests that the Moon was once part of the Earth that separated due to rapid rotation. Now, imagine the Earth spinning so fast on its axis that a chunk of it simply broke off and started orbiting around us. That's the idea behind the Fission Theory. It's like a cosmic pirouette where the Earth twirled so fast that it spun off a piece of itself into space. This theory was primarily based on the remarkable similarities in the isotopic compositions of the Earth and the Moon. However, there's a catch. For this theory to work, the Earth would have had to spin incredibly fast, much faster than it does today. But there's no evidence to suggest such a high rotational speed. Besides, the dynamics of this process are rather hard to reconcile with our current understanding of physics. While elegant in its simplicity, this theory has been largely dismissed due to lack of supporting evidence. The co-formation theory proposes that the Earth and the Moon form together from the nebula. A fascinating conjecture. The co-formation theory paints a picture of a cosmic ballet. It suggests that the Moon and the Earth were born from the same celestial nursery, a nebula, a vast cloud of gas and dust in space. According to this theory, about 4.5 billion years ago, this nebula started to collapse under its own gravity. As it collapsed, it spun faster and flattened into a disk, and out of this disk, the Earth and the Moon were born, side by side. This theory is quite appealing, as it elegantly explains why the Moon orbits in the same plane as the Earth's equator. But like a puzzle piece that almost but doesn't quite fit, it struggles to explain the differences in the compositions of the Earth and the Moon. However, this theory too falls short, as it doesn't explain the differences in the compositions of the Earth and the Moon. If you're enjoying this journey through lunar mysteries, don't forget to do a few things that can help us bring more such fascinating content to you. Look at the bottom of this video. There's a red subscribe button waiting to be clicked. By subscribing, you'll join our community of curious minds and you'll never miss a video from us. Also, if you're finding this video interesting, give it a like. It helps us know what content you enjoy and helps others discover our videos. And finally, we'd love to hear your thoughts and theories on the Moon's formation. Drop a comment below and let's get a conversation started. Now, with that said, let's continue our exploration of the Moon's enigmatic formation. The capture theory entertains the idea of the Earth capturing a wandering Moon in its gravitational pull. Now imagine the vastness of space, sprinkled with celestial bodies, each on their own journey. And among them, our Moon, drifting aimlessly until Earth's gravitational force snags it. That's the heart of the capture theory. It paints a picture of a rogue Moon, an interstellar drifter caught in the Earth's cosmic lasso. But it's not as simple as a cowboy roping cattle. The Earth's gravitational pull would have to be just right to capture the Moon without sending it hurtling into our planet or slingshotting it back into space. The Moon, in this scenario, would have been a spectator to Earth's evolution, an outsider drawn into our planetary drama. Despite its romantic notion, this theory has its own set of challenges, mainly the difficulty of capturing a body into a stable orbit. The giant impact hypothesis, or Theia impact, suggests a collision of titanic proportions. This theory, proposed in the 1970s, paints a picture of a violent and chaotic early solar system. The protagonist of this theory is Theia, a hypothetical planet said to be about the size of Mars. The giant impact hypothesis proposes that around 4.5 billion years ago, Theia was on a collision course with our young and still forming Earth. This was no gentle merger, but a catastrophic crash, sending an incredible amount of energy and matter into space. The aftermath of this cosmic car crash was a swirling, glowing cloud of molten rock and vaporized elements. The Earth, though scarred and heated by the impact, survived. But what of Theia? And what about the debris cloud orbiting our planet? Well, according to the giant impact hypothesis, Theia's mantle, a large part of its mass, was either ejected into space or absorbed by Earth. The rest, along with the debris from Earth's outer layers, began to orbit our planet. Over time, gravity did its job, pulling together these fragments of Theia and Earth, compacting them into a single solid body. This, the theory suggests, is how our moon was created. This hypothesis helps explain why the moon lacks easily vaporized elements and why it's compositionally similar to Earth's mantle. It also provides a plausible explanation for the moon's large size relative to Earth and the moon's peculiar orbit. Currently, the most accepted theory. It does explain many of the moon's and the Earth's characteristics, but it's not without its own set of puzzles. For instance, the precise dynamics of how a collision could result in the current Earth-Moon system are still being unraveled. And then there's the question of why the Moon and Earth have such similar isotopic compositions, an unusual trait not seen in other planet-moon systems. Even with these questions, the giant impact hypothesis remains a compelling and dramatic explanation of our Moon's birth. Beyond the most accepted theories, there are more exotic ideas, like the Moon being a captured rogue planet or a relic from an ancient alien civilization. Now, let's delve into the first of these theories, the Moon as a captured rogue planet. This idea suggests that the Moon was once a nomadic planet, journeying through the cosmos until it was captured by Earth's gravitational pull. According to this theory, our Moon might not have been born in our solar system, but could have been an interstellar traveler that found a new home orbiting our planet. However, this theory fails to explain why the Moon's composition is so similar to that of Earth's mantle, making it a less favored explanation. Then we have the theory that the Moon is a relic of an ancient alien civilization. It's a tantalizing thought, isn't it? This theory is often associated with the concept of the spaceship moon or the hollow moon. It posits that the Moon, with its odd properties and anomalies, could be an artificial structure, perhaps a spaceship or an outpost left behind by an advanced extraterrestrial race. While this theory is exciting and rich in science fiction appeal, it lacks substantial scientific evidence and is generally not supported by the scientific community. There are other theories as well, like the Moon being a fragment of a now extinct planet or the product of a nuclear explosion on Earth. Some even suggest that the Moon might be a giant plasma hologram, projected by unknown entities for unknown reasons. These ideas, while fascinating, are considered too speculative and lack concrete evidence. Yet it's worth noting that all these exotic theories, however far-fetched they may seem, demonstrate the enduring mystery of the Moon's formation. They reflect our innate curiosity and our relentless quest for understanding the universe. While these theories may seem far-fetched, they remind us that the Moon's formation is still a hot topic of scientific debate. Despite the mysteries, studying the Moon provides invaluable insights into our planet's early history. It's rather like peeling back the layers of time, each layer revealing a new secret about our cosmic past. Consider lunar rocks. These aren't just ordinary stones. They're time capsules, preserving a record of the solar system's evolution that's over 4.5 billion years old. By examining these rocks, scientists can piece together the complex puzzle of our moon's birth and evolution. The moon's craters too harbor secrets. Each one is a testament to an ancient cosmic collision. Their size, depth, and distribution can tell us about the size and frequency of the objects that bombarded the moon. And since the moon has no weather or geological activity to erode these craters, they remain as pristine records of our solar system's violent past. But the secrets don't stop there. The moon's lighter highlands and darker seas, or maria, hint at a time when the moon's surface was molten, a lunar magma ocean. This idea suggests that the moon's crust solidified from this ocean, with lighter minerals floating to the top to form the highlands and heavier ones sinking to create the maria. And let's not forget about the moon's strange asymmetry, with one face towards Earth and a far side that's thicker and more mountainous. This could be due to the tidal heating from Earth's gravity, or perhaps an ancient collision with a second moon. But perhaps the most intriguing secret is that the moon's composition closely mirrors that of Earth's mantle, a clue that supports the giant impact hypothesis. It suggests that the moon was born from the debris of a colossal collision between Earth and a Mars-sized body. As we continue to explore the moon, who knows what other secrets we might uncover about our cosmic dance partner and, in turn, ourselves.